DRDO is rapidly advancing its hypersonic missile capabilities to counter regional threats, particularly from China and Pakistan. It is developing weapons that travel at speeds exceeding Mach 5, over 6,000 kilometers per hour, making them nearly impossible to intercept due to their maneuverability and reduced reaction times. At the heart of these efforts lies Dhvani, India's hypersonic glide vehicle, a boost glide missile system designed for evasive high-speed strikes. Dhvani builds on technologies validated by the Hypersonic Technology Demonstrator Vehicle (HSTDV) that has undergone rigorous trials since 2019, laying the foundation for future operational systems. India's Dhvani Hypersonic Glide Vehicle is a boost glide system capable of reaching Mach 6, over 7,400 kilometers per hour. At roughly 9 meters long and 2.5 meters wide, Dhvani is launched by a solid rocket booster that lifts it to 30 to 40 kilometer altitude. From there, it detaches and glides unpredictably, using aerodynamic lift and sharp turns to dodge interception. Unlike ballistic missiles that follow a high, easily tracked arc, Dhvani's low glide path allows mid-flight corrections, plasma stealth from atmospheric friction, and sustained hypersonic speed without needing constant propulsion. This makes it far more evasive than supersonic missiles like BrahMos, which are limited to Mach 3 and straight-line trajectories. Even scramjet cruise missiles, which rely on continuous air-breathing engines, don't match Dhvani's flexibility. Globally, it rivals China's DF-17 in maneuverability but leans on indigenous materials for scalable production. Future deployment could include Su-30 MKI fighters or submarines, offering versatile launch platforms. Dhvani's heat resistance is built on carbon-carbon composites and active cooling using endothermic fuels, allowing it to survive re-entry temperatures above 2000 degrees Celsius. Its guidance system combines inertial navigation with satellite and terrain matching, achieving accuracy within 10 meters, even during plasma blackouts. It can carry payloads between 300 to 500 kilograms, including conventional or nuclear warheads, and potentially reach distances from 1,000 to 5,000 kilometers, doubling the range of Agni-V in some setups. This precision not only boosts strike capability but also reduces collateral damage, aligning with ethical warfare principles amid rising regional tensions. The Dhvani program builds on DRDO's earlier hypersonic technology demonstrator vehicle, launched in 2008. It's boosted by solid rockets and separates at 30 kilometers to ignite its scramjet engine, enduring extreme heat through titanium alloys and niobium internals. Despite international tech restrictions, DRDO developed its own thermo-structural materials and wave rider aerodynamics to maintain stable hypersonic flow. Collaborations with Israel on wind tunnel testing and Russia on engine design helped accelerate progress, with development costs around $30 million. These breakthroughs laid the foundation for a broader hypersonic ecosystem. The extra long-duration hypersonic cruise missile ET-LDHCM complements Dhvani with scramjet-powered endurance for extended loitering strikes. The hypersonic cruise missile HCM aims for Mach 6 to 8 and uses HSTDV's ignition tech for air launch from fighter jets. Under Project Vishnu, DRDO plans 12 variants by late 2025, including anti-hypersonic interceptors using directed energy lasers. The BrahMos-II upgrade merges supersonic legacy with scramjet propulsion, extending its range to 800 kilometers while maintaining Indo-Russian collaboration. Technological innovations underpin these systems. Ceramic thermal barriers outperform steel under extreme heat, and flame stabilization enables powered glides at air speeds over 1.5 kilometers per second. Precision targeting at hypersonic speeds require AI-enhanced seekers that resist jamming, while miniaturized warheads support swarm tactics. Strategically, Dhvani reshapes regional dynamics. Pakistan, reliant on slower Shaheen missiles and early-stage hypersonic tech from China, faces interception windows under 5 minutes. This renders air defenses like HQ-9 ineffective and shifts the Kashmir equation in India's favor. Dhvani creates an asymmetric advantage, deterring incursions by threatening instant unblockable retaliation. Against China, whose DFZF HGVs dominate the Indo-Pacific, Dhvani helps close the gap. India's fourth test in 2024 reportedly reached Mach 8, and future variants may stretch to 10,000 kilometers, covering strategic zones like the Taiwan Strait or South China Sea. This enhances India's second strike nuclear credibility and stabilizes deterrence during border standoffs, though it risks triggering an arms race if China boosts exports to Pakistan. Challenges remain, including scaling production amid supply chain constraints and countering enemy hypersonic defenses like railguns. Still, 2025 milestones suggest growing maturity, with Dhvani's final test expected by year-end and induction targeted for 2029. India's push for self-reliance not only strengthens its borders, but also unlocks dual-use benefits like reusable satellite launchers and hypersonic surveillance drones, reshaping South Asian security in a rapidly evolving global landscape.